Hi, I'm Cassie, and I'm going to walk you through question 52 of the AAMC's official physics question pack to help you prepare for the MCAT. So, this question is all about understanding how light travels, and specifically understanding what a photon is and how it can interact with atoms. So, let's break it down. We want to know why light is going to travel more slowly through optically dense mediums, like for example through glass, than through less optically dense mediums, like say through air. So first of all, it might seem obvious, but what is light? A lot of times we forget that light is made of a bunch of photons, and photons are just these massless particles that carry energy. So let's say we have a material, like let's say we have glass, for example. Well, glass is going to be made up of a bunch of atoms. So let's draw one atom, and we're just going to draw this simplistically. So, this is going to be my nucleus here. I'm just going to draw as this big black dot, and of course, we've got our protons and neutrons in that nucleus, and then we're going to have our orbitals around our nucleus that are going to contain our electrons. And of course, this is the Bohr atomic model. It's really outdated at this point. We know today that electrons don't actually stay in these perfect circular orbitals. Today we have this quantum model of where our orbitals are, which essentially tells us that our orbitals are probably in these shaded regions, a probability map of where we're going to find our electrons. So like most likely our electrons we're going to find them here for the 1s orbital, or for the 2s orbital they're going to be more like in this ring shape, etc., so on and so forth. So this is the modern model that we actually go by today, and this is the old outdated Bohr model. But again, for simplicity of drawing, I'm going to go with the old Bohr model for this question. So let's say that I have an electron, and I'm just going to draw my electron as this orangey particle here in one of my orbitals. And we're going to have light that's going to come and pass through our glass. And what that's going to look like on an atomic basis, looking at a single atom, is that photons are going to come through our atoms, and they're going to interact with our electrons. So specifically, they're going to hit some of the electrons and get absorbed by the electrons. And remember, we said a photon is just energy with no mass. So that energy that the electron absorbs, that photon, is going to cause it to get excited. And when it gets excited, it's going to jump up to the next orbital. And I think of the electron like a little kid in this case, and the little kid, it just got a piece of candy, like the photon, and they got really excited, so they jump up. Right? So here, this is going to be our electron absorbing a photon. And we know that when it jumps up orbitals, it gets into an excited state. But just like a little kid who has a piece of candy, they're going to have a sugar crash pretty soon, right? So that electron is not going to hold on to that energy from that photon for very long. What's going to happen is that electron is going to re-emit, so it's essentially going to let go of that energy from the photon, and it's going to go back to its original energy level. So it's going to step down from the orbital it was in, and in the process, it's going to release that energy it had absorbed. So it's going to release that photon. So we're going to say that this is emitting a photon. So now this is just looking at a single atom, but we're going to have photons coming all through our medium here, right? All through our glass and interacting with a bunch of different electrons, and those electrons are going to be jumping up and getting excited, and they're going to be emitting the photons and jumping back down. So this whole process, I would compare it to like if you're trying to cross through a really crowded room. If light in the form of photons is traveling through a really dense medium, just like if you are traveling through a room that's packed with people, it's going to slow you down, right? You're going to be bumping into people, and they're going to be bumping into you, just like those electrons are going to be absorbing the photons, and they're going to be emitting the photons. And the end result is that it's going to take you longer to get to the other side of the room, and it's going to take that light longer to get through that more optically dense medium. And remember, how do we see that light slowing down, those electrons absorbing and re-emitting those photons? How can we see it with our naked eye? Well, that's just, we can think of Snell's law, which is like if this is air on top a medium, and if this is glass, and if we have our photon, our ray of light, is going to hit that medium. Well, we know that if we draw our normal line here, perpendicular to our medium, and that if this is our incident angle, theta I, that light, those photons, are going to bend closer to the normal, so that our theta r here, our theta r is going to be less than our theta I. And remember, we have the mnemonic FST. When light travels from a less dense medium, where it travels faster, like air, for example, to a more dense medium, where it travels slower, like glass, for example, it's going to bend towards the normal. So that's that T there, towards the normal. So again, this is what we see. We see that light bending, just like when you put a straw in water, it looks like that straw bends. But on the atomic level, what's happening is that those electrons from the atoms of the glass are absorbing the energy from the photons that are passing through it and re-emitting them. So the correct answer is going to be option A for me, which says that light slows down because it gets absorbed and re-emitted by the atomic structure of a more optically dense medium. Now let's look at why the other answer choices are wrong too, because answer choice B for me is the exact same, except it says that the light is absorbed and re-emitted by the nucleus of the more optically dense medium. So why is that wrong? Well, remember we said that those photons, they're interacting with our electrons here, there. They're not interacting with our nucleus. And there's a couple of reasons for that, but to simplify, you can just think of the fact that our nucleus is really big. It has all these protons and neutrons in it, and our electrons are really small. So those photons, with the energy that they have, it's going to be much easier for them to interact with the electrons, these small little particles, and influence them, than it is going to be for them to interact with this giant nucleus full of all these positive charges from our protons. So that's why answer choice B for me, which says that the light is absorbed by the nucleus, is wrong. Now, there's also answer choice C, which says that the light bounces around randomly inside of an optically dense medium. So that's not true. The motion of our photons is not going to be random. For an electron here to absorb a photon, that photon has to match the exact amount of energy that the electron needs to jump to the higher orbital, to the higher energy level. So there's nothing random about that process. And just like when you're trying to cross a crowded room and get to the other side and go through some door on the other side, your motion is not random. You might get bounced around a little bit, just like those photons are going to bounce around a little bit and get passed along by the electrons, but ultimately you have a path, right? You're going in one direction, and that's how photons travel. Whatever kind of path that they're taking, they're going to follow that path. They're just going to get absorbed by electrons and re-emitted by them along the way. So light's movement is definitely not random. And then our last answer choice, why is it wrong? Well, it says that the light loses amplitude as it travels through an optically dense medium. This is one of those questions where the MCAT just throws in an answer that sounds like it could be true, but is not really relevant to the question. The question is all about the speed that light is traveling and how the optical density of a medium influences it. It has nothing to do with the amplitude of light. The amplitude of light is about its intensity, not about its speed. So again, that would be the first answer choice that I would cross off as a distractor answer choice. So I hope this explanation helps. If it helps, please drop a like and subscribe to my channel for more content like this.